Hey, Mr. Harridan here. We're going to go over percent yield problems. Now, there is a percent yield formula, which is experimental over theoretical times 100. The experimental value is actually what you made in an experiment. The theoretical is calculated from stiochiometry. Okay, so it's going to be experimental over theoretical times 100 to determine how much we made in the lab. Okay, because not all experiments go perfectly, just so you know. Okay, let's look at an example here. 32 grams of methane at STP are burned in a combustion reaction. Oh boy, combustion reactions. And 30 grams of water are actually produced. What is the percent yield? Okay, so we are looking for the percent yield of the reaction. If 32 grams of methane at STP, 32 grams of methane. Okay, that is what we are starting off with in theory. Are burned in the combustion reaction, and 30 grams of water, 30 grams of water, this is your actual value, are actually produced. What is the percent yield of this reaction? Now, here's the thing. You have to have the same substance here. This is methane and this is water. So you can't just go actual over theoretical times 100 and be done. No! You have to have grams of water over grams of water to figure out the percent yield. So first thing we have to do here is write down the reaction. Hopefully you remember those combustion reactions. Like methane is CH4 plus O2 goes to CO2 and water. Balance the reaction here, so we're going to put a 2 in front of the water and a 2 in front of the oxygen. In this problem we are going to start off with 32 grams of methane. We are going to convert this over to the actual, so we need to get the grams of water. Okay, so step 1 here, go from grams to moles using the tape. Step 2, you're going to use the reaction to go over to moles of water. And then step 3, you're going to use the tape again to go up to grams. So this should be a 3-step problem here. Did I leave myself any room to work this? Not really. We'll pretend I have left some room to work this. I'll do it down here. Sure, Mr. Harridan. So you're starting off with 32 grams of CH4. Put my scribble underneath here. Hey, that's actually a brown pen. I don't know if you've ever seen a brown pen, but yeah, it's a brown pen that writes brown. So 3 steps here. Step 1, gotta use the tape. Grams on the top, grams on the bottom. What am I trying to convert to? Moles. CH4. Tape says 1 mole. Tape says molar mass of CH4 16.505. So molar mass of CH4. Okay. Step 2, because our first step is to go to moles. Step 2, mole to mole ratio, which brings in the reaction. Moles on the top. I should go back to my brown pen. Moles on the bottom. Moles of CH4 on the top. Moles of water on the top here. Moles of CH4 on the bottom. These cancel. Those cancel. Okay. Because remember, we're trying to get 2 grams of water. So now we do our wham 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 wham. Wham 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 wham. 1. Wham 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 wham. 2. Then we do the last step here, which is another tape step. Moles on the top, moles on the bottom. What are we trying to convert? 2 grams of water. Moles on the tape says 1, and I know the more mass of water is 18.02. Multiply, divide, multiply, divide, multiply, divide. Get an answer. 71.86 grams of water. That is not a percent yield. You have to do percent yield next, which is experimental over theoretical times 100. Remember, you should never get a percent above 100. So my experimental here, theoretical is 71.86. The experimental was 30 times 100. And we round percents to 2 decimal places, so it's 41.74% efficient. Easily done. Now let's do a harder one. The reaction, the combustion of methane. Oh my goodness, we've got to do another combustion reaction. Oh, those reactions are important. It's only 74.3% efficient. How many grams of water would you actually expect from 90 grams of liquid octane burned? Boy. So we got 90 grams of liquid octane burned. That's a theoretical number. I got my percent yield here. What am I looking for? How many grams of water would I actually expect? From an experiment, so that's an experimental value. So this is octane and that's water, so yeah, we're gonna have the right reaction here. So hopefully you know that octane is C8H18, and we're gonna react this with oxygen. And combustion reactions always produce CO2 and water. Hey, you know this happens in an internal combustion engine, don't you? In your car. Yeah, because your car takes gasoline. Okay, this is another one that you have to double here. Trust me when you balance this. This is like 2, and this is like a 25, and this is like a 16, and this is like an 18. Okay? So now I'm going to make my map here. Go from 90 grams of octane to grams of water. So the first step here is to go down to moles of octane with the tape. Then you're going to go over to moles of water with the mole to mole ratio from the reaction, because you know I like to do tape reaction tape. So this one's going to be 3 steps here. So we're going to start off with 90 grams of octane. Three conversion factors. Oh my goodness, I can actually fit my answer here. Go figure, Mr. Harriman. And we're looking for grams of water. This is going to be theoretically produced. So step 1, gotta use the tape. Grams on the top, grams on the bottom. What are we trying to convert to? Moles. Moles is always 1. Gram says molar mass. I know the molar mass of this. It's 114.26. Remember, I'm figuring that out from the periodic table, correct? I'm doing 8 times 12.01 and 18 times 1.01 and figuring out the molar mass. Okay, that's step 1, these swish. Step 2, we gotta do the reaction. Moles of octane on the bottom, moles of water on the top. Then we wham, 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 wham. Wham, 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 wham. 18. Wham, 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 wham. 2. And the final step here, we go back to the tape. Those canceled. Moles of water on the bottom, grams of water on the top. What does the tape say about moles? It always says 1. What does it say about grams? More maths, 18.02. Multiply, divide, multiply, divide, multiply, divide. 127.7 grams of water. Now I'm going to take that and use it in the percent yield equals actual, nope, not actual, experimental. I gotta use the word experimental, Mr. Harridan. Experimental, because it came from an experiment, Mr. Harridan, over theoretical, times 100. Hopefully I remember to multiply the other one times 100. We'll see. Okay, so here we go. This is 74.3 equals, because that's the percent yield. Experimental is what I'm looking for. Over 127.7 times 100. So what I'm going to do is I'm going to cross multiply these two first. And I don't have a calculator here. Awesome. Awesome. Because I'm going to get rid of fractions first. So then I get 9,488,11 equals experimental times 100. So now I divide by 100. Then I can do that in my head. And I end up with a final answer of 94.88 grams of water in the experiment, which was easily done. Okay, you guys are champions. The legend is out.